we're going to look at supernova, in particular type 1a and type 2 supernova. First of all, type 1a supernova. This is a kind of supernova that occurs in binary systems. One of the binaries has to be a white dwarf, and the other star can be anything from a giant star even to a smaller white dwarf. And this is how it appears. Here you have the white dwarf, and this is the companion star. What happens is that the white dwarf, which is quite compact, quite dense, is going to suck some of the material away from the larger star, and it basically spirals into the white dwarf in a accretion disk, and then it will explode, become a supernova. A type 2 supernova results from the rapid collapse and violent explosion of a massive star. So this is your regular large mass star. It's ending, it turns into a neutron star and basically explodes. This is a type 2 supernova. So these stars must have at least 8 times and no more than 40 to 50 times the mass of the Sun for this explosion. This is the one where the core that is left has to be greater than 1.4 solar masses. And this is the Chandrasekhar limit. And this is what happens at the end. The star gets ripped apart and this is what's left. What happens here, the white dwarf, which is on the left, is sucking some of the material, some of the matter from the larger star, and it spirals in on this accretion disk, but then it becomes unstable and then ignites and then explodes. We will have to look at why that is the case, why that happens. So a dying star, what's left of the star, the white dwarf, which is left with a carbon or oxygen core, is actually smaller than the Chandrasekhar limit. Because it's quite massive, it sucks in matter from a binary companion into this rotating accretion disk, which then falls into the white dwarf. But this is going to add some energy, and it's going to add some mass to the white dwarf. This increase in mass and temperature causes the mass to go over critical value. And then it goes over the Chandrasekhar limit. So this then undergoes this collapse where it overcomes this electron degeneracy, which means that atoms basically get crushed into each other, and then this ignites the supernova, and then you have this massive explosion where approximately 10 to the 44 joules are emitted in a matter of seconds. And this will cause an emission of about 10 to the 9 times the brightness of the Sun. Astronomers can identify type 1a supernovas because they happen in a very similar way. The accretion process is identical from one supernova to another, so they all have the same luminosity. And therefore they can be used as standard candles. Type 2 supernova. A type 2 supernova results from the rapid collapse and the violent explosion of a massive star. The star must have at least 8 times the solar mass, and no more than 40 to 50 times, because these are going to turn into black holes. First of all, we know that hydrogen and helium fusion takes place in the shell, and then this core collapses and the helium fuses to carbon and oxygen. Nothing strange there. But then it collapses again and you will start to produce heavier elements. You get these shells, these concentric shells, which are burning in different layers as hydrogen is formed to helium, helium to carbon, carbon to oxygen, oxygen to neon, and so on. And we end up with an iron core. Eventually the star does not produce enough radiation to support the rest of the star, because the production of iron doesn't really give any more energy. And then it basically goes into free fall. There's no radiation pressure to support the star. So what happens is the electron degeneracy is overcome, matter gets crushed into matter, atoms are crushed into each other, and the nuclei basically fuse together, and you get this massive production of neutrons and neutrinos. But as it falls and it gets to the smallest point, the neutron degeneracy stops further collapse. The neutrons cannot crush into each other. And then you get this rebounding shock wave which goes upwards and slams into the outer layers. And then the surface temperature of the star goes from 4,000 Kelvin up to 20,000 Kelvin in seconds. And this is the supernova explosion. What is left is a neutron star. When you observe these two kind of supernova, the brightest one is the type 1A one, the one with the accretion disk. The second one is a little bit dimmer, which is the type 2 supernova. The type 1A is more luminous. The type 2 has this characteristic plateau after 20 days or so.